All right, hello everyone. This is Mr. Crozier, and this is part 3. We're going to solve this equation. And solving trig equations is one thing. It is getting it to the point where you have a trig function, any one, and you have a trig function of something is equal to a number. So we have to simplify it down to this. And once we get down here, we can use a unit circle if it's on the unit circle, or a calculator if we need to. So here we go. Well, first thing I see is this has a 2 out here, so let's divide by 2. Now I have sine of this crazy thing is equal to root 3 over 2, and this is on the unit circle, but what do we do when we have a sum right here? Well, we use this sum formula. We do all 1, 2, 3, 4 parts of the sum formula. So here we go. It would look like sine of this one would be sine of x times, I'm going to put the formula sheet here so we have it, sine of x, now cosine of pi over 2, would that be a 0, plus cosine of the first one, well that's just cosine of x, and sine of the second one, sine of pi over 2, well that's way up there, that's 1, is equal to root 3 over 2. And it looks like we made the problem messier, but actually we didn't, because 0 times anything is 0, and I'm left, and 1 times cosine is cosine, and look what I'm left with. I'm left with exactly what I wanted to get. I have a trig function with just the letter there is equal to a number, and that's on the unit circle. So where is cosine this? Well, that's pi over 6 and 11 pi over 6. All right, so that's our plan. This is the line we are going for. Then we use our unit circle knowledge, and we have those values. All right, next problem. We have cosine sine of x. And again, our plan is this. I'm going to write it right here. We want to get to sine or cosine, doesn't matter, of something is equal to a number. But here's the problem. We have x here and 2x here, and those are vastly different. So, well, this is a double angle formula. I can take cosine and write it into one of these. I can rewrite cosine as this, or this, or this. And I'm going to pick this one right here. Why am I going to pick this one? I'm going to pick this one because I already have a sine right there, and then everything will be in sine, and that will probably be easier. So this changes, oops, let's make that a 2, sine squared x sine x plus 1. Using the double angle formula, I have changed this into this. So now what have I done? Everything has just one thing, x, x. There's no more 2x. There's just x's. All right, how do we solve this? Well, squared, it's going to be a factoring problem. So why don't I move this over here? That would be 2 sine squared x plus sine x. And why don't I subtract away the 1? Hey, those are gone. This is 0. So now I have this, and where do we go from here? Well, it's a factoring problem. I could factor out a sine, and I'd have 2 sine x plus 1. Let me double check that. If I multiply sine times this, I'm back here, and if I multiply sine times that, I'm back there. Very good. And what have I done? I've given myself 2 different versions of this up here. I mean, this is our main plan up here. This is where you're going for on every problem. You're going for that. And what have I done? I've given myself 2 of those right there and right there. Use your unit circle knowledge. You figure this out. This is what? 0, pi, and 7 pi over 6, and 11 pi over 6. All right, and the last one. Again, where am I going for? I'm going for sine of a single letter, an argument it's called. I have x here and x over 2 here. These are vastly different, so can't use it. But what I can use is, hey, that's set up for half angle. I'm going to use this sine half angle right here, and it's going to change it into cosine. Hey, and that's cosine right there, so not too bad. I'm going to use that formula sheet. What do I have here? Sine half angle. I'm trying to get it so you can see it here. 1 minus cosine. So I have the square root, plus or minus, not sure yet. 1 minus cosine x over 2. And why don't I just for fun put this over here? All right. Now I'm trying to get to x, but it's under a radical. If I square both sides, now I have cosine x, 1 minus cosine x over 2. This would be cosine squared. Now, do you see why I put that over there? If I let's take this equation over here and look at it a different way. If I don't put that over there, let's say I leave that cosine there, which is a fair thing to do, and I go to square both sides, which is a fair thing to do. This side is 0, and this side will require me to do foiling, so I'll have to write this twice and foil it, and it's going to be a lot of work. So if you can get the square root by itself, it makes life a lot simpler over here. So this is a long way. We're not going to do this over here. It's going to be a long way to get to the answer. I'm sure you'll still get there, but if I move this over here and I square it, the math's a lot easier. All right, what do we have to do here? Let's finish this. Times it by 2, both sides. Solve a quadratic. Well, by now, hopefully, we know it's factoring. 0. And let's see here. Factor that. I came up earlier today with 2 cosine x minus 1 cosine x plus 1. Factor it. Cosine x is 1/2. Cosine x is -1. What are the solutions? Pi. 3 pi over, whoops, not 3 pi over that. How about just pi over 3 and 5 pi over 3? Those are my solutions, but wait a minute. I squared both sides, and once I square both sides, you have to make a note. You are bringing in the chance for extraneous solutions. So going through, we need to take these and plug them back into this equation. So if I plug that back in there, I'm going to check them over here. You can do some of it in your head. It's not as long as it looks, but you can check them. Pi over 3 divided by 2 would be sine of pi over 6 minus cosine of pi over 3. See what I did is I took this and I plugged it in there, and it changed it to that. And I took that and I plugged it in there, and it just stays the same. What's the sine of pi over 6? Well, the sine of pi over 6 would be 1/2 minus, what's the cosine of pi over 3? 1/2. 1/2 minus 1/2 is 0. Good solution. This will check, that will not check. That is an extraneous solution brought on when we squared both sides, and you always have to check them if you square them. All right, hope these help with the equations.